Hi, my name is Rosalinda, and today we'll be going over question number 5. A person pulls a toboggan for a distance of 42.2 meters along the snow with a rope directed 33.4 degrees above the snow. The tension in the rope is 85.7 N. How much work is done on the toboggan by the tension force? How much work is done if the same tension is directed parallel to the snow? The formula we'll use to calculate the work done is going to be W equals force times distance times cosine of the angle. Beginning with part A, how much work is done on the toboggan by the tension force? We're going to know that the rope is at 33.4 degrees. The force given to us is going to be 85.7 N. The distance is 42.2 meters. And the angle will be 33.4 degrees, our rope. So once we plug that in, we'll do W equals 85.7, which is our force, times 42.2, which is our distance, and times cosine of our angle, 33.4 degrees for our rope. The cosine of 33.4 degrees will give us about 0.83487. Once we multiply all this out, we get a total of 3019.2 J for part A. That is how much work is done on the toboggan by the tension force. Now for part B, how much work is done if the same tension is directed parallel to the snow? If the rope is parallel, then our degree is going to be 0 degrees. So for the force, it doesn't change, 85.7 N. Our distance also doesn't change, 42.2 meters. But our angle does change, which is going to be 0 degrees. So we plug this into W equals 85.7 force times 42.2 distance times cosine of our angle, 0 degrees. We know cosine of 0 is 1, so once we plug that in, we get a total of 3,616.54 J. This is going to be our final answer for part B, which is how much work is done if the same tension is directed parallel to the snow. On to question number 10. A pole vaulter just clears the bar at 5.46 meters and falls back to the ground. The change in the vaulter's potential energy during the fall is negative 3,300 J. What is his weight? If the pole vaulter just clears the bar at 5.46 meters, we know the change in height goes from 5.46 meters above ground to 0 meters. So it gives us negative 5.46 meters for the change in height. Next, we want the change in potential energy, which is going to be negative 3,300 J. The formula for change in potential energy we'll use is the weight times the change in height. And we want to get the weight alone, so we do weight equals change in potential energy over change in height. And we'll plug in our values of negative 3,300 J over negative 5.46 meters, which gives us a total of weight equals 604.395604, and we'll round that to 604.4 N. And that is our final answer for his weight.